My name is Hooria Amir and I am presenting the correlation analysis in SPSS. Correlation is used to find the degree of association between two or more variables. It is useful to indicate the predictive relation between these variables. If we want to find any relation between two variables, we use correlation analysis. It also gives us the degree of correlation present between the variables, whether that they are directly or inversely related to each other, and it also gives us the information about how strongly or how weakly they are related. There are some applications of a correlation analysis, like if we want to find the relationship between height and weight, we use correlation. If we want to find the relation between an income of a person to the years of experience, then we use the correlation analysis. Same case is seen in case of price of a product and its public demand. Correlation do have some limitation as it does not employ the causation, which means that it will not tell us which factors are causing the deviation from the middle line. It is difficult to find which value is dependent and which is independent in correlation analysis. There are two types of correlation analysis. Number one is a Pearson's R correlation, which is mostly used. It is a parametric statistics which uses the continuous or the linear data only. As the data is purely linear, the graph will be made linearly. The second type is Spearman's rank correlation, which is a non-parametric statistic which uses a categorical and continuous data. Its graph always increases or decreases but never linear. In the first type, Pearson's R correlation, the small r indicates the regression. This technique was introduced by the Carl Pearson. He used two variables which have the linear data. Pearson's correlation coefficient ranges between -1 to +1. If we draw a number line at +1 peak and the -1 peak, then we get a middle point at the 0. On that 0, there is no relation present. But when we go from 0 to +1 or from 0 to -1, stronger relation will be seen between two variables. At the positive one, positive relation present. At the negative one, the negative relation is present. Here is a graph. Both are linear lines shown on a graph. One is purple and a green. Both of these have the same correlation coefficient, but as you can see, purple is more steep than the green one, but both have the same correlation coefficient. Why? Because correlation is not about the steepness of the line, it's about how close the data points are to the model line. Now I am discussing the sign and its value and the relationship. If the sign of the coefficient correlation is positive, positive relation is present. Positive relation will be strong if its value lies between 1 to 0.5 range. The relation will be moderate if it lies between 0.49 to 3 range. It is weak when it lies between 0.29 to 0.1 range. It is weak or considered to be non-existent at 0.09 to 0, because at the 0 no relationship is present or no correlation will be present. At the negative values, negative relation will be found. It's a strong relation present at -1 to 0.5 range. The negative relation is moderate when its value lies between 0.49 to 0.3. Weak negative relation is present when its value lies between 0.29 to 0.1, or very weak or none is present when the values lies between -0.09 to 0. Here I have a data of students with different genders and the age group who have just passed a maths, English and general knowledge test, and their score is given here. Here I use zeros for female and 1 for male, their age and their hours of study, maths scores and the English scores. Now I am relating the two linear variables like math scores with the English scores to run a Pearson's correlation test. First we go to analyze and then correlate bivariant because we have two variables. Now I am putting my variables, which is maths and English, as I want the Pearson's output, so I check this box and remove this. Test of significance, I choose two-tailed because I am not sure where on positive peak or negative peak my data will lie, or my results will be. And the flag significance correlation is ticked because it will help to find the significant correlation, as it adds the one is steric when the level is 0.05 and 2 is steric when the level is 0.01. Okay, now we are applying it. The output pop-up which shows the column. Here the math scores are related to the math scores, and these math scores are related to English scores. When we correlate the same variables, the Pearson's correlation value is 1, which indicates that there is a strong relationship present between these two, as they are identical. The n value indicates my sample number. Mostly these diagonals and these diagonals are same, so we don't consider these because they are for the same variable. The off diagonal values are important. Now we see that the maths correlation with the English correlation, the Pearson correlation value is 0.798 steric, double steric. 0.7 value indicates a strong relation between the math scores and the English scores, and this correlation is calculated significantly at 0.01 level. Now our second type of correlation is Spearman's rank correlation. It was introduced by the Charles Edward Spearman. He was the pioneer of the factor analysis. He used two variables to measure the ordinal scale. The variable he selected should have the monometric relation between them. Monometric relation is actually that both of these variables should increase together, or one variable if increases then the other should decreases. If we plot a graph like this with ordinal data, it will be formed like this. These are the data points. When we plot a straight line, we see that these points are deviating from the model line, which shows that there is no linear relation present, but they are increasing. Opposite case is seen here when the data line is decreasing and it shows no linear pattern but decreasing factor. Now we are going to apply the Spearman's rank correlation, it is also known as Spearman's row correlation, to the two ordinal data. Here I am calculating the hours of study with the general knowledge scores. We will go to analyze, correlate, bivariant, and I am going to add my variables in this column, general knowledge. Now I will check the Spearman's block, two-tailed test, flag significance, yes. Now the output is non-parametric correlation, which indicates that our data is non-parametric, or this test is for non-parametric data. Here we will get the Spearman's row. The students are correlation coefficient is 1 when we study hours are correlated with the study hours, but when we are correlating the study hours with the general knowledge score, its value will be 0.663 double steric. It indicates the moderate relation or nearly strong relation between study hours and the general knowledge. 20 is my sample size, and this correlation is significant at the level of 0.01. That is how we calculate the Pearson's R correlation and the Spearman's rho correlation. Now we are comparing these two correlation, Pearson's R correlation and the Spearman's correlation. In the Spearman's R correlation, the interval scale is used for measurements, whereas in the Spearman's, ordinal scales are used for taking appropriate measurements. In the Pearson's correlation, we measure the linear correlation so that there is no significant outlier are present as the data is linear. Whereas in the Spearman's correlation, we measure the rank order correlation because we calculate the two extremes like maximum or minimum in this correlation. All the data will be lying between these two extremes. In the Pearson's correlation, we use a linear relationship between x-axis, x variable and the y variable. Whereas in the Spearman's correlation, we use it when we want to find the relationship between the variables which are not linear but have the monometric relationship present between them. The parametric data is used for the Pearson's correlation, on which the samples are selected randomly and normal distribution is seen, whereas in the non-parametric data, samples are not selected randomly and the categorical as well as the continuous data are collected. Thanks for watching.